Is that thing running? Yeah. So, what is the sine of pi over 6? So it might help you. I don't know if it does or not. Here you go. This is pi over 6, pi over 4, pi over 3. What is, where do we coordinate to this point right here? Root 3 over 2, 1/2. So the sine is 1/2. All right, so it's 1/2. How about a pi over 3 now? A pi over 3, the sine is root 3 over 2. What about pi over 2? What about the very top of the circle? 1. Now, 2 pi over 3 is going to match pi over 3, but I have to check on the SIGN. So is this positive or negative root 3 over 2? Positive. Quadrant 2, y is still positive. How about 5 pi over 6? 1/2. How about pi? 0. Now, 7 pi over 6. Negative 1/2. 4 pi over 3. Negative root 3 over 2. 3 pi over 2, straight down. Negative 1. Now 5 pi over 3. Negative root 3 over 2. How about 11 pi over 6? Negative. And then 2 pi, we're right back to where we started. So we are at 0. Now, I'm going to plot these. You plot them. You might want to get your calculator out. You might want to get your calculator out to help you with the decimal values. They're all going to be the same, but you might not know what they are. Getting started. So, obviously, 0 wasn't even on here. I'm going to go ahead and do 0. At 0, the sign is 0. So I'm going to start with that point. Then at pi over 6, I'm at 1/2. What's root 3 over 2 decimally?
I know.
It's not 1 point anything. What is it? 0.87 or 6, something like that. So up here. Pi over 2 is 1. 2 pi over 3 is another one of those 0.86 numbers. This is a 1/2. Pi is 0. And then this is negative 1/2. Negative 0.86, negative 1. Negative 0.86, negative 1/2. Let's connect our dots. That, my friends, is one period of the sine curve. The sine curve has a hill, and then it has a valley. One period. What happens if I kept my table going? Well, the next value in the table would be 13 pi over 6. But what happens if, where's 13 pi over 6? The same place as 1/6? So you see why we just start over again? It would be exactly the same picture as I go around the circle again. So 1 revolution is 1 period, 2 pi. Notice that the amplitude or the height of these hills is 1. Does that make sense to you? That this curve is never going to go higher than 1? On many levels, it should make sense. First of all, we're coming off the unit circle, and the maximum value on the unit circle is 1. But even going back further than that, sine is opposite over hypotenuse. You learn that geometry. So, Katoa, what can you tell me about the opposite side and the hypotenuse? Hypotenuse is always bigger. So is there any way that fraction's ever going to be bigger than 1? No. So your sine values are going to oscillate between -1 and 1. Okay? So we filled all that in. Properties of the graph. amplitude is 1. Amplitude is the distance from the midline. Now with this curve, your midline is the x-axis. That's the middle of the graph, is the x-axis. Now you know we can pick these things up. And so that midline can change. The amplitude is the distance, I think of it as the height of the hill. So the amplitude is 1. Okay? Midline is y equals 0 for this one. Period is 2 pi, we already talked about that. Frequency is the reciprocal of the period. So if the period is 2 pi, then frequency is 1 divided by 2 pi. And be careful when you write that. Don't write it this way. That's half pi. It's got to be 1 over 2 pi. So don't be doing the slant thing, okay? It's too confusing. 1 over 2 pi.
For the sine curve and the chart, is it just not necessary to graph the pi over 4?
Yeah, we could, and the more points we plot, the better our picture's gonna be, obviously, but there's no point in it. They're gonna fall in here, and we're gonna end up. So we actually graphed maybe the more than we needed to. Yeah, no, it's fine. And then, okay, oscillates between being concave down and concave up. Okay, pretty obvious. Would you do the same thing on the next page for the cosine? So fill in your chart and draw your picture for the cosine. I know he's got the circle right there. Try to do it without that. Obviously, if you get stuck, use it. But try to do it without his unit circle. that what yours look like?
Yeah.
Now, would you agree that all the characteristics we talked about with the sign, midline, amplitude, period, frequency, would you agree those are all the same with a cosine? Your midline is still the axis. Your amplitude, the height of the hills, is still 1. It is exactly the same picture, just shifted over. Does that make sense to everybody? Okay. A sinusoidal function is any function that involves additive and multiplicative transformations of these curves of the sine. The cosine is sinusoidal because a cosine is a moved sine curve. If I were to pick this picture up and back it up pi over 2, then it's a sine curve, right? Cosines and sines are both sinusoidal because they can both be thought of as sine curves. Okay, all right. Before we look at the next one, I want to make sure you understand what frequency is. We know what period is. Period is from beginning to end before I start repeating again. After this, I would just start repeating again. That's what period is. So if you look at this picture, which is just some made up thing, the period of this picture is 4. Would you agree? And the period of this one is 1/2. Agreed? Now, frequency is calculated as the reciprocal of the period. But what frequency means is how many complete periods are accomplished in an interval 1 unit long. So if you look at only 1 unit, right here, 1 unit, how much of my curve gets drawn in that little section?
125.
1/4 of it. So that's the frequency. So then you come over here. Now this is 1/2, so 1 is clear out here. How many periods get drawn if I go all the way to 1? 2. So your frequency is 2. Okay. I know radios are probably outdated. People never listen to a radio, I'm sure. But you know there's like AM and FM channels. That A stands for amplitude modulation. So AM radio, they're changing the height of the curve, the sound waves. These are like sound waves. FM, guess what that stands for? Frequency modulation. So that is changing how close together the waves are. Cool, cool. I think it's cool. Example 1, here we go. Bryce is up here rolling his eyes. Example 1, 2 periods are shown. Okay, so what is the period of this function? Pi. Hill, valley, 1 pi. What's the frequency then? 1/pi. What's your midline this time? In other words, where are the hills sitting? On y equals 3. Remember, the midline is a line, y equals 3. What is your amplitude? Whoa, 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 whoa. Your midline's at 3. How high are those hills? 3. Okay, so let's make sure we're clear on this. Amplitude is half the distance from the top to the bottom, because amplitude is just the height of the hill. So 6 is the height of a valley and a hill. It's got to be half of that. Amplitude is just the hill, or just the valley. Got it? All right, next. Number 2, several periods are shown. what is the period? Pi over 2. Which means your frequency is 2 over pi. What is your midline this time? What is it? Y equals 1. The midline is halfway between the bottom and the top. So the bottom is at -1, the top is at 3, the middle of that is 1. Everybody okay? Sometimes it helps to like draw it in. What's your amplitude then? 2. Perfect. Okay, now example 3. All right, now things are getting a little interesting. We have a sinusoidal function. And it has a maximum point at pi 8. So there's the maximum. The first minimum after reaching this is at 3 pi over 2 -2. Okay, so this is the maximum, this is the minimum. Okay? So can you tell me what the period of this is? Now, when you look at a sinusoidal function, don't you have a maximum? I mean, a period is maximum to maximum, right? So and then the minimum is halfway in between there. So how far is it from the maximum to the minimum? Pi over 2? Half pi? So where is the next maximum going to be? 2 pi? So what's the period of this function? Pi, which means its frequency is 1 over pi. Now where's its midline? Well, the max is at 8, and the min is at -2. What is right in the middle of 8? I'm doing midpoint, middle. Yep.
Wait, that point says 3 pi -2.
Yeah.
Oh, sorry. Oh, I'm sorry. Okay. I'm sorry. Thank you. Thank you. That changes things. Okay, so this is 3 pi -2. All right, we can still do it, right? Sorry about that. I copied it wrong. How far is it from max to min now? 2 pi. So another 2 pi will put me at my next maximum. So what's my period now? 4 pi. Yeah, sorry about that. 4 pi. Which means your frequency is 1 over 4 pi. Now, midline, right here, somewhere in there. The average of 8 and -2 is 3. So the hill is how tall? 5? 3/8. So that's your amplitude. Oh boy. Here we go. All right, you've seen this before. All right, so what have we got? We're going to have some kind of sinusoidal thing going on here. And we have to figure out what these points are. We need point F and G and J and K and P. So before we start like labeling that, let's figure out what's going on. We have our clock on the wall. It has, here's the clock on the wall. It has an 8-inch hand. And the center of the clock is 120 above the floor, the center of the clock. At time t equals 0, the minute hand is pointed directly up. So at 0, the hand's up here. So what point would that be? This is time, and then that is distance. So 128. Everybody okay with that? All right. Now, when is it up there again? When is it going to be up at 128 again? After 30 minutes? So 30, 128, and then again at 60, 128, and so on, okay? Now, halfway in between, so at 15, the hand is straight down?
Yeah.
How high is it then? 112. When is the next time it's at 112? 45. Now, what about in between those? So what about like 7.5? Well, wouldn't it be over here? Which means it is 120. And then over here, which would be 7.5, 15, 22.5. It's at 120 again. Are you with me?
Yeah.
Now, we got a bunch of points. We got to get them on our graph. And the first time we did this, we struggled a little bit because we weren't sure where to put the points. But remember, this is X and this is Y. So 128 is the highest Y I have, right? So this point and this point have to be the 128s. So 0, 128, and 30, 128. Now the lowest point I have is 15, 112. Would you agree with that?
Yeah.
And then these guys are in the middle, so this will be my 7.5, 120. And this will be my 22.5, 120. Now let's stop there. These problems keep coming back. Is everybody okay with that? Okay. Now, okay, we got them labeled. Find the period, frequency, amplitude, and midline. Okay, what is our period? 30. And actually, the unit on that, I didn't put a unit on my other periods, and I certainly could have. When we were graphing the sine and cosine off the unit circle, that would have been radians, 2 pi radians. This would actually be 30 minutes, right? Okay, what else do I want? Frequency. What's my frequency? 1/30? What's my midline? My midline this time is y equals 120. And my amplitude is 8. The radius of the clock there. Everybody good? Okay. Our next step, by the way, after we talk a little more, will be to write the equation of that curve. You're going to be able to do that. Okay, but first we have to answer this question. Find 2 intervals for which the graph is both decreasing and concave up. Decreasing and concave up. Do you see one interval up there that's that way? Julia? From where? F to J. Now, I gotta be careful going F to J, because this is actually concave down.
So G to J.
So G to J would be decreasing and concave up. Would you agree with that? So 7.5, 120, well actually I want an interval. So from 7.5 to 15, that interval is decreasing and concave up. Okay. Is there another one up there? Well, there are millions. You just have to find another one. Is there one right here? Okay, so what would that be? What would the x coordinate of this point be? 37.5. And what would the x coordinate of this point be? 45. So from 37.5 to 45 would be another one. Guys, when you look at a sine curve, think about the chunks of the sine curve. This is increasing and concave down, decreasing and concave down, decreasing and concave up, increasing and concave up. So, when you have to identify these sections, each curve only has one section. So you're gonna have to look at the next period. Notice, what's the difference from here to here? 30, one period. One period. Every period is gonna have that same characteristic. In this case, decreasing and concave up. Okay, perfect. All right, next page. I forgot to number these. I'm so bummed. The back of the spaghetti page. The back of the next page. Number 11. Forget about all the spaghetti things. They're just having you model this. Forget about that. We're talking about a cosine curve. How long does it take until the cosine curve starts repeating? 2 pi. That's the period of it. 2 pi. What do the graphs of sine and cosine have in common? Well, almost everything. What do they have in common? They have the same amplitude, the same period, the same frequency, the same midline. Okay, so what's different about them? Their starting point, their zero. In a sine curve, the zero was here, right? But in a cosine curve, the zero was here. So if I call that the starting point, that's what's different. They're shifts of each other. Now, quickly, can you sketch cosine over the interval from negative 2 pi to 4 pi? Now, clearly, that's more than one period. Can you do that? I think you can. You have already sketched this much of the cosine. You've already sketched this. That's what we took off the first revolution of the unit circle. That's your cosine. So what happens in the next period? Same thing. And what happens in the period that happened before that? Same thing. In some ways, we love our sines and cosines because they repeat all the time. In other ways, we find them boring because they repeat all the time. All right, next page. Why is the range of both the sine and the cosine negative 1 to 1? We already talked about this, but let's talk about it again. Why is the range negative 1 to 1? Give me a good reason. Yeah, they come off the unit circle. We're talking about x and y values on the unit circle. And the furthest out you can go is 1. Right? Yeah. How many full cycles of the sine can be graphed in this same interval? Now that's a cosine. But how many periods? 3. Because negative 2 to 4 is 6, and a period's 2. So 3 periods. Is cosine even, odd, or neither? I can't even remember if we talked about this. Did we talk about even and odd? All right, let me throw some information at you. Even means you have symmetry about the y-axis. An even function has symmetry about the y-axis. So I'm looking up here at my cosine. Here's the y-axis. Does that picture have symmetry across the y-axis? Yes, it does. This cosine is even. Now, how that manifests itself in terms of, for you guys, is if I say find the cosine of pi over 6, I hope you'll all say root 3 over 2. If I say find the cosine of negative pi over 6, remember, negative pi over 6 would be down here. Isn't that also root 3 over 2? With even functions, your input SIGN does not change your output SIGN. So with an even function, f of x will be the same as f of negative x. Perfect example. X squared. What happens if you put in 2? You get 4. What happens if you put in negative 2? You still get 4. Sine, SIGN, of input does not impact output. Okay, that's what even means. Cosine is even. That means that without a calculator, you could tell me that the cosine of 100 is the same as the cosine of negative 100, because it's even. All right, now what about sine? Well, this is sine. Is sine even? No way, Jose, because even, if it were even, it would have to look like this, which it doesn't. It is actually odd, because its symmetry is across the origin. If I said to you, find the sine of pi over 6, I hope you would all say 1/2. But the sine of negative pi over 6, keep in mind, here's pi over 6, here's negative pi over 6. That would be negative 1/2. So with an odd function, changing the sign on the input changes the sign on the output. Sine is odd. Okay? All right, let's see if we can get 5 done. Determine if each statement is true or false about the cosine. F of x equals f of negative x. True, cosine is even. The graph of the cosine has a y-intercept at 1. True. The graph is concave down on its entire domain. No. Remember, each piece has different concavity and direction. The x-axis represents the cosine ratio. Do these numbers represent the cosine ratio? No. No. Now, is cosine x over r? Absolutely. But the x-axis doesn't represent that. F of 146 pi is 1. Yes. Because 146 pi is 73 revolutions. It's just going to put you right back at 0, isn't it? And last one. F is undefined for negatives. No. Can you find the cosine of negative things? Absolutely. All right. Have a good day. Ooh. Got a lot done today, Michael.